Okay, so this is chapter 2.1, question number 15, I believe. And it said, let me go to that. It said right here, in exercises 11 through 16, write a function g whose graph represents the indicated transformation of the graph of f. Use a graphing calculator to check your answer. And then in parentheses, it said, see example 2. So this is the problem we're going to do, but I want to go to example 2 and we'll look at that first. So here is example 2, and it says writing reflections of functions. Let f of x equal the absolute value of x plus 3, and then plus 1 on the outside. So this is a shift left 3 and up 1. So if I graph that in Desmos right now, and right here, so it was the absolute value of x, absolute value, now I forgot what the function was, x plus 3 in absolute value, and then plus 1 after. So it was x plus 3 plus 1. Okay, so what that does is it takes the vertex, which with the parent function, let's graph that, absolute value of x. Okay, the parent function is in blue. So if you, the vertex is at 0, 0. If you shift left 1, 2, 3, and up 1, we are now at the new function. Let me just zoom in a little so it shows every grid mark. Right there. Left 3, up 1. So inside plus is left, outside plus is up. All right. So now getting back to, so that's this graph right here, x plus 3 plus 1. So it says, part B, write a function h whose graph is a reflection of the y-axis of the graph of f. So we're going to reflect it in the y-axis, the vertical axis. So we want to skip to B down here. So a reflection in the y-axis changes the sign of each input value. So h of x is going to equal f of negative x. So what we're going to do is, first of all, say h of x equals f of negative x, which is to multiply the input by -1. And that would get us over to the other side of the y-axis. Okay, so it says, right, and then it says, next step, replace x with -x in f of x. So here's f of x. So all we did was take this x and make it negative, because it says f of -x. So now x is negative. Once we do that, we then want to get rid of that negative sign. And so we distribute, we factor it out. So when you factor out a negative number from a parentheses, okay, so if you think of this as -1 here, -1 times x is -x. -1 times a -3 is +3. This is the distributive property in reverse. Factoring is the inverse of distribution. Okay, so once we do this, there's a -1 out front now, not just that negative sign. And then what the book is telling us is we can take that -1 and put it in its own absolute value bracket and multiply it by the other absolute value. So really we're factoring out the absolute value of 1, the absolute value of -1, and moving it out and multiplying. Okay, so once this -1 is here, we're factoring it out. It's factored out, but we're going to leave it in absolute value brackets. And I think that's where the confusion was with your steps. So when I -1 just doesn't go away, but the absolute value of -1 is +1. And then it's just multiplying by 1 is the identity, so nothing changes. So what happened here was when you multiply by -1 absolute value, we're now left with x minus 3, and the -3 is the only thing that really changed. We went from x plus 3 to x minus 3, because 3 is not, since the -1 got factored out, it changed the sign between x and 3, and this absolute value of -1 is now going to be +1. So that will go away, if you will, or it's 1 times the absolute value of x minus 3 plus 1. Okay, so if I graph this now, the absolute value of x minus 3 plus 1, if I now graph that, the absolute value of x minus 3 and then plus 1 outside, okay, this is the green one. So as you can see, here is my y-axis right here, and this red V got reflected over to the other side at 3. So the vertex was negative 3, 1, and now the vertex is 3, 1. All right, so now let's take a look at the problem in the homework. I just wanted to go over the example that they said to use in the homeworks. Now let's go on to the problem. So let's follow the steps. It says f of x equals negative 3 plus the absolute value of x minus 11. So in class, you did say, yes, let's put this in standard form so the constant's at the other side. So we can rewrite this as the absolute value of x minus 11 minus 3. Okay? Let me put that minus down here. Okay, the absolute value of x minus 11 plus a negative 3 is the same as just minus 3. Okay, so this is getting shifted right 11, down 3. So let's graph that and the parent again. So if I go back to Desmos, I'm going to graph the absolute value of x. That's the original parent function. And then we're going to graph the absolute value of x. And it's minus 11 minus 3. So it's going to be minus 11 inside, which is shifting it right 11. And then minus 3 outside would shift it down 3. So then when we look at that, sure enough, we went from 0, 0 to 11, negative 3. Right 11, down 3. Okay? Opposite inside, same outside. Opposite of minus is plus to the right, down on the outside. Okay, so now that we've done that, we've graphed the parent function, we've graphed this function. Now we want to graph a reflection in the y-axis. So where do we want our, let me zoom out so it doesn't go off the screen. We want our vertex, which is right here, to be negative 11, negative 3, which would be right here. Okay, so how does that happen? Well, what's the first step? We're going to be going back and forth now. Step 1, multiply the input by negative 1. So if I go back to this, f of negative x is going to equal absolute value negative x minus 11, close the absolute value, minus 3. Okay, so all I did was this step right here. I made the x negative. Now we're going to put parentheses around it and move that negative outside. Whoops, next page. Okay, so now I'm going to say f of negative x equals absolute value negative parentheses x plus 11. Because if I distribute this now, negative 1 times x is negative x. Negative 1 times a positive 11 is negative 11. Close the absolute values. The minus 3 does not get changed. Now I can rewrite this as f of negative x equals the absolute value of negative 1 times the absolute value of x plus 11 minus 3. So then when I simplify this, the absolute value of negative 1 is 1, and 1 times anything is that anything because it's the identity. So it's going to just become x plus 11 minus 3. And we want to call that when we're done g of x instead of f of negative x. So g of x equals x plus 11 absolute value minus 3. Now if I graph it, absolute value of x plus 11 minus 3, then I'm going to do absolute value x plus 11 minus 3. And sure enough, it ended up at negative 11, negative 3, where the vertex here was 11, negative 3. So that is a reflection in the y-axis. It was shifted left 22 spaces from this to be a reflection over here. Okay, hopefully that helped. Okay, so here's problem 44. Thought-provoking. Yeah, it is a little bit. This is a tough question. You are planning a cross-country bicycle trip of 4,320 miles. Your distance d in miles from a halfway point can be modeled by d equals 72 times the absolute value of x minus 30, where x represents the time in days and x equals 0 represents June 1st. So that means we're going to start this bicycle trek June 1st. So if x is 1, x is 2, x is 3, we can determine how far we've gone and how far we are from the midpoint. Your plans are altered so that the model is now right shifted of the original model. In other words, you couldn't go on June 1st. Now you're going to leave later. That's going to shift the entire model, and your starting time and end time are going to change with. So it's a right shift of however many number of days d you're delayed. That's what this question's saying. So give an example of how this can happen and sketch both the original model and the shifted model. So let's start by graphing the original model. 72 absolute value of x minus 30. So I'll go to Desmos. 72 absolute value x minus 30. Okay, enter. And I have to zoom out and find it. And I'll have to fix my window here because it is really steep. And as you can see, it is going way up to, so what's the y-intercept? Well, when is this thing 0? That's what the question is. So if I look at this, I don't want to go negative. So look how far out I have to go before I cross. So it's right around 5,000, just under 5,000 here. Actually, let me go back to the problem, and it tells you 4,320 miles. So if I change my window, let me move me out of the way, and I change my window to say 4,500 instead of negative, I only want to go to 4,500. 4,500. Oh wait, not the x-axis. Actually, I want that 0. I don't care about what's before 0 because that's my starting point. And let's say 5,000. And y-axis, let's start that at 0 and go to 5,000. Okay, so there's 5,000 there, but I don't want to go way out to 1. I want my x's to stop. I'm not even at 200 right here. 200, 400, 600, 800, 1,000. I'm not even at 200. So I'm going to change my x to maximum 200. And that will spread it out so we can see this a little better. There, that's better. Okay, so here's our model. And 0 is at 30, 0. Okay. All right, so there's our graph. So we want to shift this thing to the right. And that's what this question is saying. So let's go back to here. And it says function d of x equals 72 times the absolute value of x minus 30 represents a distance from the half point. This means that when d of x equals 0, number of days equals d of x equals 0, you've reached the half point, the halfway point. So let's calculate that point. That's what you want to do. So you want to take 72 times the absolute value of x minus 30 equals 0, and we want to solve that. So in order to solve this for 0, we divide both sides by 72. So the absolute value 2 has 2 solutions, though. Whenever you have an absolute value of x minus 30, there's going to be 2 solutions, the positive and the negative. So when x minus 30, when what's inside the parentheses is greater than or equal to 0, and when x minus 30, what's inside the absolute value bracket is less than 0. So in order to do that, we're going to do the first case first, and that is going to be take x minus 30 is greater than or equal to 0. So x minus 30 absolute value has to equal x minus 30. Okay. So 72 times the absolute, the absolute value is gone. 72 times this So in the absolute value of x minus 30 equals x minus 30, that would be a positive value. So we're going to just use that first. So you plug this into this. So 72 times x minus 30 equals 0. We're going to distribute, get 72x minus 2,160 equals 0. Add 2,160 to both sides. So I get 72x equals 2,160. Divide both sides by 72, and we get x equals 30. Okay. That was actually pretty simple if you look at it, because if 30 minus 30 is 0, 0 times 72 is going to be 0. So what has to be, what's in the absolute value brackets has to equal 0 to get 72 times 0 to equal 0. And so we got 30. The other scenario is when x minus 30 is negative. So in other words, the absolute value of x minus 30 equals the opposite. So we're going to multiply by -1 like we did in problem 15, and that's going to give me negative x plus 30. It just negates everything. The opposite of positive x is negative x, the opposite of minus 30 is plus 30, and we take that value and multiply it by that 72 and set it equal to 0. So 72 times negative x plus 30 equals 0. Distribute, you get negative 72x plus 7,000 or 2,160. Subtract 2,160 over to the other side. Divide by negative 72, and we get 30. Okay, so then we're going to divide both sides by negative 72, and that will give us 30 again. So there's the second case scenario. So what does that mean? It means you'll reach the halfway point in 30 days, meaning that the trip will last for 60 days. So if the model is a right shift of the original model, that means the new model is d of x equals 72 times the absolute value of x minus h minus 30. Remember, a horizontal shift is when you have an h inside the absolute value bracket, and it's moving the x, changing the x value. So x minus some h value. So that comes out to be when you multiply, or you can get rid of those absolute value or the parentheses in the absolute value. So these parentheses can go away, and it's just simply 72 times the absolute value of x minus h minus 30, where h represents a shift to the right. So let's do a scenario. Let's say h, did I do this in here? No, I didn't. Let's do h equals 10 right here. So let me move this down. So if I took, and let's say we, whoops, Control Z, pen. So what this means, H represents a shift to the right, meaning days. We're changing the number of days that we are delaying. So let's say we can't go on, what was it, June 30th. Let's say we have to delay 10 days. So that would mean H equals 10. So if that happens, then we are going to get a function. Let's just say C of x, I don't know, it doesn't matter. They call this D of x. So let's say C of x equals 72 absolute value x minus 10 minus 30. So C of x would be 72 times x minus 40 absolute value. So if I graph that in Desmos, so it's going to be 72 absolute value, oops, absolute value, x minus 40, enter. Okay, so here's what happened. So if we left, this is day 0, it would take us 30 days to get halfway. Now we're delaying it 10 days. We're moving to the right on the calendar, if you will. So the graph would look the same. It would take the same amount of time to get to the halfway point. It would take the same amount of time to get to the end of that over 4,000 mile trek, but we're changing our dates so that the whole function got shifted to the right. And that's all this question was basically saying. Long story short, all they were doing was a horizontal shift based on a certain number of days. And I just chose 10 to explain what would happen after 10-day delay.